So welcome, this is CIE May June 2010, paper 43. There are 7 questions. We shall try to solve all the 7 questions. So the first question, 3 coplanar forces act on a point. The magnitude of the forces are 5.5 newtons, 6.8 newtons, 7.3 newtons, and the directions in which the forces acting are shown in the diagram. Given that the resultant of these 3 forces is in the same direction as the magnitude of 6.8 newtons, so it is in this direction. Find the value of alpha and so on. So first of all, what am I going to do? I am going to resolve this 7.3, one vertically and one horizontally. So this becomes 7.3 cos alpha. This becomes 7.3 sin alpha. Now upward force is equal to downward force. So 7.3 sin alpha is equal to 5.5. From there, I get sin alpha is equal to 5.5 divided by 7.3. So we can get alpha is equal to sine inverse of 5.5 upon 7.3. Do by calculator, it should be giving you 48.9 degrees. Now 6.8 newtons is in the horizontal direction, it is in the forward force, and my backward force is 7.3 cos alpha. So the resultant will be forward force 6.8 minus backward force 7.3 cos alpha, which is 48.9 degrees. So simplify by calculator, it should be giving you 2 newtons. That's going to be the answer. Second question. A particle starts at a point O and moves along a straight line. Its velocity t seconds after leaving O is this much. Find the displacement of the particle from O when the acceleration is 0.6 meter per second. So velocity has been given as 1.2 t minus 0.12 t square. Find the derivative of that. It becomes acceleration 1.2 minus 0.24 t. So acceleration is 0.6 is equal to 1.2 minus 0.24 t. So from that 0.24 t is equal to 1.2 minus 0.6. So t is equal to 0.6 upon 0.24, which becomes 2.5 seconds. Find the displacement of the particle. So in order to find the displacement, we have to find the integration of the velocity. So between, find the displacement when its velocity. So from 0 to 2.5 seconds. So the limits will be 0 to 2.5 seconds. So integral 0 to 2.5. Then the integration of 1.2t is 0.12 square. 1.2t plus 0.12t minus 0.12 t square dt. So it becomes 1.2 t square upon 2 minus 0.12 t cube upon 3 from 0 to 2.5. 0, the lower limit need not apply, only apply the upper limit. 0.6 times 2.5 whole square minus 0.04 times 2.5 whole cube minus 0 minus 0. Simplify that, it should become 3.125 meters. That's going to be the answer. Now coming to the third question. A load is pulled along a straight horizontal track from A to B by a force of magnitude P newtons, which acts at an angle 30 degrees from the horizontal. A load, there is a load. It is on a horizontal track. It's on a horizontal track. It is pulled by force of magnitude P newtons, which acts at an angle 30 degrees upwards from the horizontal. The distance AB is 80 meters. So A to B is 80 meters. The speed of the loader is constant, and which is 1.2. The speed is going to be 1.2 meter per second as it moves from A to the midpoint of AB. Let it be C. For the motion from A to M, so he has already given M, so we cannot write C, so let it be M. For the motion from A to M, the value of P is 25. Calculate the work done by the force as the load moves from A to M. So from A to M, he is asking us to find it out from A to M. So work done. Work done is equal to nothing but what? force times distance. Force times distance. So we need to know the force. We know that it is P newtons. So I resolve that one into two components. The forward force will be P cos 30, the horizontal one, and the vertical one will be P sin 30. So it is moving because of P cos 30. And the distance is, it is halfway, therefore 80 divided by 2, which is 40. So to make it easy to understand, I write 80 divided by 2. Now P is given as 25, so cosine 30 times 40. Simplify this one. This is going to give you 866 joules. Next, the speed of the load increases from 1.2 meters per second as it moves from M2 towards B. For the motion from M to B, the value of P is 50. The work done against the resistance is same as at the from A to M. The mass of the load is 35 kgs. Find the gain in the kinetic energy of the load as it moves from M to B. Hence, find the speed when it reaches B. So, we are going to use work energy theorem. What is that? Total work done is equal to delta KE plus delta PE plus work done against friction. Now, from M to B, total work done will be force times distance. Force times distance. Now, the force is P cos 30 times the distance is the remaining distance, which is nothing but what? 40. So P was 50 this time, cosine 30 times 40. This is the total work done. Delta KE. Final kinetic energy, we have to find it out. Half M. M is 35, I think so. The weight is given as 35 kgs. Half mv square minus half m u square. U square is nothing but what? 1.2 square. Delta P is equal to 0 because it is not moving up or down. Plus work done against friction. Work done against friction is nothing but what? Which was 866. 866. So we can calculate that one over here. 1 upon 2, 35 times v square minus 1 upon 2, 35 times 1.2 square plus 866. So I want the value of v over here. So 1 upon 2, 35 times v square is equal to 50 times cos 30 times 40 minus 866 plus 1 upon 2, 35 times 1.2 square. So v square is equal to 2 times 50 cos 30 times 40 minus 866 plus 1 upon 2 times 35 times 1.2 square whole divided by 35. Simplify this and find the square root of entire this one. You should be getting the answer as 7.14 meter per second. That's going to be the answer. So I used work energy theorem. Now coming to question number 4. The diagram shows the vertical cross section of a triangular prism which is fixed so that these two faces are inclined at 60 degrees to the horizontal. One of these faces is smooth and other one is rough. Particles A and B passes through masses 0.36 kgs and 0.24 kgs respectively are attached to the ends of a light inextensible string which passes over a smooth pulley fixed at the highest point. B is held at rest and the cross section is a rough face while A hangs freely and it is a smooth. So this is a rough and this is smooth. B is released and starts to move up. B is going up. So tension, and this is B is 0.24 G sine 60. 0.36 G sine 60. By considering the motion of A, show that the tension in the string is 3.03. So for A, forward force, it is going downwards, 0.36 G sine 60. minus backward force tension is equal to 0.36 A. Acceleration has been given as 0.25. That's it. Very simple. Make T as a subject. 0.36 G sine 60 minus 0.36 times 0.25. This should be giving you something around 3.03 newtons. Find the coefficient of friction between D and the rough surface. Correct to two significant figures. Now for B, the forward force, it is going upwards, minus backward force is equal to Ma. The forward force is a tension, minus backward force is nothing but what? 0.3. Backward force is 0.24 G sine 60. 0.24 G sine 60 minus any another backward force, the frictional force. Frictional force is mu r is equal to Ma. Is equal to Ma. M is nothing but 0.24 and acceleration is A. So now what am I going to do it at? The tension. Tension is 3.03 minus 0.24 G sine 60 minus mu we have to calculate R. R, the normal reaction is nothing but what? 0.24 G cos 60 is equal to Ma 0.24 and acceleration. Acceleration is 0.25. From this, make mu as a subject. Mu times 0.24 G cos 60 should be equal to 3.03 minus 0.24 G sine 60 minus 0.24 times 0.25. From there, mu value will be equal to 3.03 minus 0.24 G sine 60 minus 0.24 times 0.25 upon 0.24 G cos 60. So let us see and take the calculator and do that one. So 3.03 minus 0.24 times G is 10 times sine 60. Keep the mode of the calculator in degrees. Minus 0.24 times 0.25 divided by 0.24 times 10 times cosine 60. Simplify that in two decimal places, it should be 0.74. So that is the value of mu. Coming to question number 5. A ball moves on a horizontal surface of a billiard table with a deceleration of constant magnitude d meter per second square. The ball starts at A with a speed of 1.4 meter per second, reaches the edge of the table B 1.2 seconds later with a speed of 1.1 meter per second. Find the distance AB and the value of D. So its final velocity, initial velocity is 1.4, final velocity is 1.1, time is equal to 1.2 seconds. So we can write the units. So we can use V is equal to U plus AT. So V is 1.1, U is 1.4, A we don't know, T is 1.2. So A will be equal to 1.1 minus 1.4 divided by 1.2. So I take the calculator, 1.1 minus 1.4 divided by 1.2. It is, so acceleration is minus 0.25 or the deceleration is 0.25 meter per second square. So I got the deceleration, but what is being asked is also asked to find the distance AB. So V square is equal to U square plus 2AS. So V square is 1.1 square is equal to 1.4 square plus 2 times A is minus 0.25 times S. So from there S is equal to 1.4 square minus 1.1 square upon 2 times 0.25. Simplify that. This should be giving you something 1.5 meters. That's going to be the distance. AB is at right angles to the edge of the table containing B. The table has a low wall along each of its edges and the ball rebounds from the wall at B and moves directly towards A. The ball comes to rest at C where the distance BC is 2 meters. So what is happening? It will bounce back and BC distance is 2 meters. This was 1.5 meters. So AB was 1.5, so BC is 2 meters. Find the speed with which the ball starts to move towards A and find the time taken for the ball to reach B to C. So from B to C. So final velocity at C is going to be 0. Initial velocity is, we don't know, let it be U. Now distance it has traveled is 2 and it is going to be having the same deceleration, which is minus 0.25. So I use v square is equal to u square plus 2as. So 0 square is equal to u square plus 2 times a is minus 0.25 because it is the same surface, so same deceleration times the distance is 2. So from there u square is equal to 4 times 0.25, which is 1. So u is equal to 1 meter per second. So it will rebound with 1 meter per second. So find the speed with which ball starts to move towards a 1 meter per second and time taken for the it to reach. For that, what are we going to do? V is equal to u plus at. So 0 is equal to 1 plus minus 0.25 times t. So t is equal to 1 upon 0.25. So time is equal to 4 seconds. Next part of the question. Sketch the velocity time graph of the motion of the ball from the time ball A leaves A until it comes to rest C, showing the axis of the values of the velocity and the time taken when the ball is at A, B and C. So we are drawing a velocity time graph. So origin, time in seconds, velocity in meters per second. Now at in the beginning we know that at A the velocity was 1.4 meter per second square and it becomes at 1.1 meter per second in 1.2 seconds. So when the 1 point, maybe I take 1.4 velocity, it becomes 1.1 and it was 0, it became this and in 1.2 seconds. So it came down with 1.2 seconds. Then it rebounds. It rebounds and moving in the direction minus 1 meter per second, right? Its velocity was 1 meter per second. So, but what is in the opposite direction? So at now this was at A, this was at B. Now again at B it starts over here because it is going backwards in the direction, backward direction with a velocity 1 meter per second. So it is B and minus 1. Then at after 4 seconds, so 1.2 plus 4 seconds is nothing but what? 5.2 seconds, its velocity will become 0. So you join a line from 1.2 comma minus 1 to 5.2 comma 0. So this is going to be the part B and C. In this way the ball moves. Coming to the sixth question, the particles P and Q move in on a line of greater slope of a smooth inclined plane. P is released from rest at a point O on the line and 2 seconds later it passes through point A with a speed 3.5 meters per second. Find the acceleration of P and the angle of inclination of the Q. So particle P moves on a greatest line of a smooth inclined plane. P is released from rest at a point O on the line and 2 seconds later it passes through P. So P is coming from here and it comes through A. This angle is theta and its speed is 3.5 meters per second 2 seconds later. What is the acceleration? So initial velocity is 0, final velocity is 3.5 meters per second, time is equal to 2 seconds. So V is equal to U plus AT. So 3.5 is equal to 0 plus 2A. A is equal to 1.75 meter per second square. Find the angle of inclination. So forward force minus backward force is equal to ma. So what is the forward force? Nothing. 0 minus backward. Forward force is nothing because we are not pulling it out. But apart from that, it is being pulled by a force of the weight of the body. Do we have the weight of the body? We don't have. So mg sine theta. So my forward force is mg sine theta. Minus backward force is 0 because it is a smooth surface. It is a smooth, so backward force will be equal to 0, is equal to ma. So g sine theta, cancels, is equal to a. A was 1.75. So sine theta is equal to 1.75 divided by g. So theta is equal to sine inverse 1.75 by 10. Simplify by the calculator. You should be able to get the angle as 10.1 degrees. Now, at the instant that P passes through point A, the Q is released from rest at O. Now, when it is passing that, we are releasing another body Q. At the time t seconds after Q is released from O, the particles P and Q are 4.9 meters apart. So, find the value of T. So, what is happening? So, first P is released. Then it took T 2 seconds. It traveled 2 seconds. Then it reaches A. Then Q is released. It travels T seconds. So means P has traveled 2 plus T seconds total time. It has traveled for 2 plus T seconds. P has traveled total 2 plus T seconds, whereas Q has traveled just only T seconds. So distance travel formula is equal to S is equal to UT plus half AT square. So S is equal to 0. T is T plus 2 seconds plus half A acceleration, we got it as 1.75, time is T plus 2 whole square. This is the distance traveled by P. Let it be SP. SP is equal to 1 upon 2 times 1.75 times T plus 2 whole square. Now Q is released and it travels only T seconds. It travels only T seconds. So for that also, we are going to take S is equal to UT plus half AT square. So S is SQ is equal to UT 0T plus half. Same acceleration it should be there. Then because 1.75 times T square. So SQ is equal to 1 upon 2 times 1.75 T square. Now the distance between them is nothing but how much he has given it out. SP minus SQ is equal to 4.9. So 1 upon 2 times 1.75 times T plus 2 whole square minus 1 upon 2 times 1.75 times T square should be equal to 4.9. I can take 1 upon 2 times 1.75 common. So it becomes T plus 2 whole square minus T square is equal to 4.9. So 1 upon 2 times 1.75 T square plus 4T plus 4 minus T square is equal to 4.9. T square cancels. So 4T plus 4 should be equal to 4.9 times 2 divided by 1.75. 4T should be equal to 9.8 divided by 1.75 minus 4. I add a page over here. So T is equal to 9.8 upon 1.75 minus 4 divided by 4. So take the calculator. 9.8 divided by 1.75 minus 4 divided by 4. This should be giving you 0.4. So T is equal to 0.4 seconds. So as simple as that, what we have to do, initially P has traveled 2 seconds, then T has traveled T seconds. So totally P will be traveling T plus 2 seconds, whereas Q is traveling only T seconds. Find the distance of P and distance of Q and subtract them, equate to 4.9. You should be getting the value of T. Coming to the last question, seventh question. Two rectangular boxes A and B are of identical size. The boxes are at rest on a rough horizontal plane with A on the top of B. Box A has a mass of 200 kgs and box B has a mass of 250 kgs. So box A is 200 and box B is 250. A horizontal force of magnitude P newtons is applied on B. The boxes remain at rest if P is less than or equal to 3150 and start to move if P is greater than 3150. Find the coefficient of the friction between the B and the flow. So total weight acting downwards is 450 G. So my normal reaction will be equal to 450 G, which is 4500 newtons. Now, so the frictional force should be equal to, because the minimum frictional force is 3150, that should be the frictional force, should be equal to mu R. So 3150 should be equal to mu times 4500. From here, I get the value of mu as 0.7. The coefficient of the friction between the two boxes is 0.2. Given that P is greater than 3150 and there no slide takes between the two boxes, show that the acceleration of the box is not greater than 2 meters per second. So, acceleration of the box is not greater than 2 meters per second. So, what is that? We have to resolve the forces only for A because we are sliding it out. A is sliding on B, right? So what am I going to do it out there? He says that no sliding takes between the boxes. So between A and B, there is no sliding at all. So what am I going to do it out? I am going to take for A, the frictional force. What is the frictional force for A? Which is mu R. Mu is nothing but what? 0.2. And R is 200 G. So this is a mu R, and this should be equal to MA. So 0.2 times 200 G should be equal to 200 A. So from there, I get the value of A as 0.2 G times 10. So which is nothing but what? 2 meters per second. So if at all it has to be sliding, so what is it says? Show that the acceleration of the boxes is not greater than 2 meters per second. So means always, whenever it is sliding, the acceleration will be always less than or equal to 2 meters per second. This is the maximum acceleration. We assume that if at all it is about to slide, if it is about to slide, my frictional force should be equal to the forward force or the driving force. If at all it is about to slide. If at all it is about to slide, the forward force should be equal to the frictional force. Then in that case, the acceleration will be 2 meters per second. Means the maximum acceleration that it can slide is 2 meters per second. So it indicates that its acceleration will be always less than or equal to 2 meters per second square. Find the maximum value of P. Now P is the forward force minus backward force is frictional force. I take it as a total system, 450 A. Forward force minus backward force is equal to MA. So P is equal to 450 plus the frictional force. So times A plus 50, 450. When will be the maximum? Whenever the acceleration is 2 meters per second. So 2 plus the frictional force. Minimum force required to make them to slide is 3150. So 450 times 2 plus 3150. So when I simplify that one, it becomes 900 plus 3150, which gives me 4050 newtons. As simple as that. So once again, I take it as a total system. So forward force minus backward force is equal to ma. We use this concept, forward force minus backward force is equal to ma. The forward force is P, which is greater than 3150, minus my frictional force. Backward force is nothing but what? Maximum frictional force is equal to ma. So my maximum frictional force will be nothing but what? 3150, and ma 450 times acceleration. Just now we have known that the maximum acceleration that which it can slide is 2 meter per second square. So therefore a is equal to 2. Substitute those values, you should be getting the answer as 4050. That's going to be the answer. That's all. That completes the paper. See you in the next paper. Bye.